Homework 7, Combinations of Functions, Video 8. In the previous video, we looked at how to add and subtract two functions and find the domain of the new functions. In this video, we'll look at multiplying and dividing two functions and finding their domains. A couple of comments before we jump into these two examples. Number one, to write the product of two functions, we'll just say fg, which means f times g. And to write the quotient, aka division problem of two functions, we'll write it as a fraction f over g. Secondly, in the previous video, the domains were always consistent between the sum and the difference. However, that ceases to be true here. You'll notice that when we create the division problem, we're creating a denominator where there used to not be one, which means we're creating a domain issue. So when you're finding the domain of the quotient of two functions, you have to avoid the second function, the one on the bottom, equal to 0. You'll see why I'm pointing that out in the second example. But let's go to the first example. Here's our two functions, f of x equals 5x plus 1 and g of x equals x plus 4. If we want to find the product of the two functions, fg of x, you literally just multiply f of x times g of x. Now, because each of these functions has multiple terms and we're about to embed them in a multiplication problem, they each need to go inside of parentheses. So 5x plus 1 times x plus 4. Should we do anything here? That's actually up for debate. I've made a new function. Here it is. I multiplied two previous functions. Would the homework accept this as an answer? Possibly. Would it want you to FOIL it out? Maybe. If you're not sure, I would click View an Example to see how they write their answer and then follow suit. But just in case, let's go ahead and FOIL this out. 5x times x is 5x squared. 5x times positive 4 is positive 20x. Positive 1 times x is positive 1x. Positive 1 times positive 4 is positive 4. And if we combine the like terms in the middle, 5x squared plus 21x plus 4. Again, the homework may accept the unfoiled answer. It may ask you for the foiled answer. So read the directions carefully. Look, it's another polynomial. Its domain is still all real numbers. So not a whole lot to look at there. But what about the division problem? F over g of x. Well, that's literally just f of x over g of x. So let's put the first function on top of the second. 5x plus 1 over x plus 4. You might be asking yourself, am I going to have to simplify this? Well, I have to cancel some stuff. Resist the temptation to cancel the x's. There's a very strict rule for when you can and cannot cancel in a fraction. In a fraction, you can only cancel parts of multiplication problems. You cannot cancel parts of addition and subtraction problems. So I cannot cancel the x up here. It's part of an addition problem. Same thing down here. Nothing in this fraction cancels. So what do we do with it? Nothing. It's done. Well, there is a way to actually do polynomial division. That's down the road. For now, we'll only consider one possible way to reduce this. It doesn't happen in this example. It will happen in the next one. So what's the domain of this guy? Wait a second. We just created a denominator where we didn't used to have one. So we just created a new domain issue. What's the one number I can't put in the denominator because it would make it equal to 0? Answer, -4. I need the domain that avoids -4. We'll start at negative infinity and stop it at -4. But that's not all of it. Those are just the numbers on the left side of -4. I have to union it with the numbers on the right side of -4. So the other interval is parentheses -4, comma, infinity. Again, when you find the domain of a quotient, a division problem, you need to avoid the denominator equal to 0. All right, let's try the second one, where we have two functions, but this time one of them is quadratic and has 3 terms. Does that change anything? Not really, but in a minute, yeah. Let's find the product, fg of x. Let's just go ahead and jump right into it. Parentheses, x squared plus 7x plus 10, close parentheses, open parentheses, 5x plus 10. Could we multiply all of this out? Saying the word FOIL is technically incorrect here. This is too big for a FOIL problem. But you could multiply it all out if you wanted to. All FOIL is the distributive property. Look back over here. See that 5x? It got distributed over here. See the plus 1? It got distributed over there. If you have larger than a binomial times a binomial, you can't technically FOIL it, but you can do a lot of distributing. For example, I could distribute the x squared across both of these, write down 2 terms, and then distribute the plus 7x across both of these, write down 2 more terms, and then distribute the plus 10 across both of these, and write down 2 more terms. Then we would have 6 terms, some of which would be like terms, then we could combine them. For the sake of time, I'm not going to do that. But if you're curious and want to try to bust it all open and combine them, I'll tell you what you should get. I'm not going to write it here, so if you want to try it, get ready to write down the results. If you were to distribute all this in combined like terms, you would get 5x to the 3rd power plus 45x to the 2nd power plus 120x plus 100. But I think the homework will accept this answer. So what's the domain? Well, there's no denominators, there's no square roots, so there's no exclusions. The domain is still negative infinity to infinity. But what about the quotient? What about the division problem, f over g of x? If I put the first function on top of the second, x squared plus 7x plus 10 all over 5x plus 10. It looks like we're in the exact same situation we were over here. I can't cancel any of those pieces. I can't cancel the 10s. I can't cancel the x's. Everything up there is part of an addition problem. Nothing in that fraction is currently eligible to cancel. However, and this does show up at least once in your homework, you can cancel parts of multiplication problems. So when you run into a fraction like this, the question you should ask yourself is, can I factor? If so, can I cancel? So there are still some factoring skills lurking around. I believe I built this problem so that it would factor and cancel. The numerator factors into x plus 2 and x plus 5. The denominator, I can factor out a greatest common factor of 5, and that would leave x plus 2. Aha! Now I can cancel. This x plus 2 is part of a multiplication problem, as is this x plus 2. They can cancel, and the homework will expect you to catch that. And that would leave x plus 5 on top and just a 5 on the bottom. And don't cancel the 5s. The one on top is not part of a multiplication problem. So sneaky, but at least I'm warning you about it. Now what's the domain? Speaking of sneaky, if you look at the final result, you might think that the domain is all real numbers because there's no longer any x's in the denominator. It's just a 5. However, go back up to what we have to avoid. There's no guarantee that this factoring and canceling would have worked. Meaning that we always have to ask ourselves what the domain is before any of that happens. In this case, we have to avoid 5x plus 10 is equal to 0. because at some point before we simplified, that was the denominator. Well, if you solve that, that means we have to avoid x equals -2, which means our interval, our domain, is -infinity, -2, union -2, infinity. So be very careful when you're setting up a quotient of two functions and you're being asked to find the domain. If the function can reduce by factoring and canceling, you're going to be expected to do that. But to answer the question about the domain, you should actually answer it before you factor and cancel.